In this lesson, we're going to be learning about the different classification of numbers, which include natural numbers, whole numbers, integers, rational numbers, irrational numbers, and real numbers. So the most basic type of classification of numbers are the natural numbers. And this is a symbol that we use to represent them. Natural numbers include numbers such as 1, 2, 3, 4, 5, and so on. They are often referred to as counting numbers. Now, natural numbers do not include 0 or any negative numbers, as well as any decimals. So, an easy way to remember this is to think of it like this. We all naturally count things starting from 1, and go on to 2, 3, 4, 5, 6, and so forth. But rarely do we count starting from 0. Therefore, this is the innermost basic classification of numbers. The next layer of numbers are the whole numbers. Whole numbers can often be denoted using this symbol. Now, the classification of whole numbers are exactly like natural numbers, in that it includes all of the natural numbers, and it also includes 0. So instead of starting from 1, whole numbers start from 0. Another cool way to remember this is to think about it like this. Whole numbers are exactly the same as natural numbers, except that they start with a number that looks like a whole. Therefore, whole numbers include natural numbers, and this means that any natural number is also considered a whole number, but not necessarily the other way around, since 0 is not a natural number. Do note, however, that the classification of these two are still a little bit hazy, as some places might teach you that natural numbers do in fact include 0, disregarding the classification of whole numbers entirely. It is common to see that in set theory or in computer science, since in these fields they actually do count starting from 0. But for the sake of this video, we're just going to include the classification of whole numbers as well. The next classification of numbers is something you are likely to have heard of before. They're called integers. Integers can often be denoted using this symbol. Integers include all the same numbers as whole numbers, like 0, 1, 2, 3, etc. Except they also include all the negatives of them as well, such as -1, -2, -3, -4, and so on. But again, integers do not include decimals or fractions of numbers. The next classification of numbers are called rational numbers, which can be denoted using this symbol. And again, rational numbers encompass all of the other classification that we've mentioned so far, as well as decimals and fractions. However, the decimal numbers must be numbers that can be expressed as a fraction, where p and q are integers, and q is not 0. So, for example, 17 over 3 is equal to 5.666 repeating, and since the numerator and denominator are both integers, this is, in fact, considered a rational number. Now, whereas this looks fairly organized with its repeating 6's, even something like 19 over 17, which yields this rather unpredictable looking decimal, would still be considered a rational number. And why? Because this is an integer, and this is also an integer that is not equal to 0. Okay, so far so good. So if I told you that I'm thinking of a number and that it is a natural number, can you assume that this number is also a rational number? Well, definitely. You can also assume that it's a whole number, since that's a bigger set. You can even assume that it's also an integer, since it's an even bigger set than that of a whole number. And finally, as we mentioned, you can also assume that it's a rational number, since rational numbers are a bigger set than the set of integers. We can compare it to something like this. If I said that there's a person in Tokyo, can we also assume that this person is in Japan? Well, obviously. As well, would we be correct to assume that this person is also in Asia? Absolutely, since Tokyo is in Japan and because Japan is in Asia. And finally, would it be okay to assume that this person is on Earth? Well, of course, because Earth is even bigger of a set than Asia. Good. Now, there's a whole different set of numbers that is not within any of these. This set of numbers cannot be expressed as a fraction. Another way to describe this is that this set is completely separate from the rational numbers altogether. Fittingly so, we can call these numbers irrational numbers. An example of an irrational number would be pi. And we know that pi is a never-ending number that does not repeat with a constant decimal or in a patterned fashion. And this is what makes it irrational. Square root of 2 also turns out to be an irrational number, since it cannot be expressed as a fraction. And lastly, the definition of real numbers is the last classification that we'll talk about. Although there are some other classifications that you might learn later on down the road. Real numbers are simply all of the rational and irrational numbers combined. So pay close attention to how certain number sets are literally in the other sets. But just remember that even though saying that a person in Tokyo must also be in Japan is correct, the reverse isn't always correct. If this person is in Japan, it doesn't necessarily mean that they are in Tokyo. Maybe they're in Osaka or wherever else in Japan. Similarly, while we can say, for example, that all natural numbers are also integers, we cannot say that all integers are natural numbers. The same applies to the rest of the layers of classifications that we've learned. So, the classification of numbers might seem random, but they will be used over and over again, so it'll be well worth your time to learn it thoroughly right away. Well, that's it for this video, guys, and we hope to see you in the next one.